Tilecast. News, features and analysis brought to you by Diary of a Tile Addict. Hello and welcome to Tilecast, your weekly podcast on all things ceramic tile, from sector-specific news to exhibitions, tile reports, profiles and features. As ever, I'm joined by Diary of a Tile Addict's Joe Simpson.
Hello everyone, welcome to Tilecast.
Okay, Joe, I understand that this week you want to go back to basics.
Yeah, that's one way of putting it. I thought today's Tilecast should be all about clay.
Now, this may seem like an odd question, but why do you want to talk about clay?
Well, there are two reasons. Firstly, nearly everyone in the tile industry, me included, takes clay for granted, but it's obviously fundamental to tile manufacture, and I think we should understand it better. But secondly, the war in Ukraine has reminded us all in the tile industry that raw materials for modern tile production are no longer dug up from a big hole by the factory, but involve a complex global supply chain featuring huge mining and chemical companies. And this is important because the selection and mix of clays has a key bearing on tile performance and aesthetics.
Fair enough, but why now?
Well, simply because my recent trip to the Techno exhibition in Rimini reminded me that not all clays are equal, and helped me to understand why the sudden loss of Ukrainian clay supplies had such a profound effect on tile production, particularly in Italy and Spain. When war broke out, the manufacturers in those countries were suddenly faced with the task of sourcing alternatives to the Ukrainian clays on which they had relied, and it was not that easy. An Affian clay, for instance, has around 78% silicon dioxide, 13% aluminium oxide, 4% potassium oxide, with every other kind of component basically at trace levels. Now, if you compare that to the UK's best known clay, Etruria Marl, and that comprises 53% silicon dioxide, 21% aluminium oxide, and has virtually no potassium oxide.
This is sounding quite geeky.
Yeah, I know. I don't want to turn this into a chemistry lesson, but it's a fact that when the closest match of available clay, mainly from Turkey, was substituted for the Ukrainian clay, it achieved pretty much the same technical performance, but the finished colour of glazed tiles was affected. And it took a lot of late-night test firing and engobe experiments to produce tiles that matched the originals made with Ukrainian clay. In short, it was a complete manufacturing nightmare, and really all came about because of quite subtle differences in chemical composition.
To be fair, a lot of us probably wouldn't even realise that Ukrainian clay was such a fundamental part of the industry. But anyway, back to your point, now that more time has passed, have geologists been able to solve this problem?
Well, sort of. It turns out that the best match for the original Ukrainian clay comes from South Africa. Well, frankly, that's better news for the tile industry in South Africa than for anyone else. The logistical costs and the ecological impact of shipping raw materials around the Cape to Castellón or Sassuolo surely makes this a non-starter.
And it's not just clay you need, is it?
No, all the raw materials used in tile manufacture are minerals, and their main component, and while the main component is clay, the other components are required to achieve the desired technical characteristics.
So this is where Jack Spratt comes in.
Just so. The various raw materials used in preparing ceramic bodies are divided in the industry into two camps: plastic or fat materials and non-plastic or lean materials. Fat materials are basically clays and kaolins. Lean materials are substances that are added to reduce plasticity or add another specific property. And the most frequently used lean materials are silica sands, alkaline feldspars, calcium carbonates, talcs, zirconium silicates and colorants.
And you need to reduce plasticity. Why?
Right, it's all to get the optimum performance when you come to actually pressing these tiles. You want something that is mouldable, but you don't want something that carries on being moulded after you've pressed it. And it's always a play-off between getting the right amount of plasticity and being able to form the thing. And there is a sweet spot, depending on what kind of tile you're making.
So of these lean materials, kaolin, silica sand and feldspar, they're the ones I've read about. Can you tell us a bit more?
Yeah, sure. Well, kaolin is a very pure white clay that's used largely when you're preparing a porcelain body, but it's also used in the pharmaceutical industry to make pills, that sort of thing. The key property it has is that it keeps its colour during the firing process. But on the downside, it's more difficult to press and requires a higher firing temperature. Silica sand is used to minimise shrinkage in the kiln, which, however, it increases the tile's porosity, reduces its mechanical strength and raises the coefficient of expansion. So again, as I was saying, it's a trade-off. You want one of the factors but you don't want the other, so it's how much you use is critical. It has to be used with care. Feldspar acts as a fluxing element at high temperature, making the mixture more reactive at a lower temperature.
And fluxing is?
Right, but this is essentially melting, or what we tend to refer to in the industry as vitrification. Essentially, you're turning a granular material into something which has more of the properties of glass and thus does not transmit water, is frost resistant, da-di-da-da-di-da. You want all of that, but you want to achieve it at an economic level, and it's got to be repeatable and consistent.
Okay, so with you so far, what about red body, white body, porcelain? What's the difference, and does it matter?
Right, okay. The plastic or fat materials, clay is the universal component used in preparing all ceramic bodies because it is easy to mould and has good hardening capabilities. Although there are numerous classifications, the most common used in ceramic tiles are based on the colour of the body, red or white. Red body clays have a high iron content, they have a low melting temperature and moderate plasticity, whereas white body types are more plastic and have little or no colouring oxides. Porcelain has a different body composition and crucially must achieve full vitrification during the firing cycle. And this is what I'm talking about. This is essentially, it must melt to become as one rather than be a granular thing that lets water through. And it must achieve full vitrification during the firing cycle, usually reaching temperatures in excess of 1200 degrees C, to achieve a water absorption of less than 0.05%. And that is the definition of porcelain. If a tile is more absorbent than that, it's not porcelain. Don't believe anybody who tells you any different. It's not porcelain. Okay,
so all these people who tell you have to seal your porcelain, it's not porcelain if you've got to seal it.
Absolutely.
Right.
Yeah, I mean, you'll find people that argue it who say, you can make a porcelain tile and then polish it and it requires sealing, da-di-da. But at the end of the day, if it's more absorbent than 0.05%, it's not porcelain.
Right, okay. So how are all these components mixed to make the clay body?
Right, basically they're done by milling, and there are two ways to do it. But in tile production, predominantly it's wet milling. And the reason that this is done is that you want a homogenised, consistent mixture which has the optimum particle size to provide the appropriate plasticity for forming. It's a lot of long words, but basically the key is consistency, plasticity, and obviously cost. So particle size is an important factor as it significantly impacts on the ease of the forming process and the drying speed of the tile, as well as influencing properties of the finished product such as colour, porosity and mechanical strength. Wet milling is expensive because it uses a lot of energy. It involves raw materials being ground in water in ball mills. So these are basically huge cylinders that rotate, and they are loaded with the clay solids, water, defocculating additives, plus the hard stones that act as a grinding mechanism.
Defocculating? You're getting nerdy again.
Yeah, okay. Defocculating elements. Basically, these are the things that help you to produce a consistently sized wet mix.
Okay, yeah, so it's evening, making it more homogenised.
Yeah, exactly so. And the resulting product is known as slurry or slip, and the particle size can be controlled by adjusting the milling time and the speed of rotation of this enormous drum.
So what happens next?
The clay slurry is then spray dried in an atomizer. So this is also a big drum, but this one's mounted vertically, where an upflow of extremely hot air at the bottom causes the water out of this slurry to evaporate. And the end result, and what basically falls to the bottom, is that consistently sized hollow spherical particles with a low moisture content, usually around 6%, ideal for dry pressing. And why does it use a lot of energy? Well, if you imagine, at the top you have basically liquid clay. By the time it's hit the bottom, you have dry clay at 6%. That requires a lot of energy.
So I think most tiles are dry pressed, aren't they?
These days, that's right. I will say a little bit more about manual pressing, slip casting and other alternatives later on. But these are really now largely confined to artisanal production or really specialist factories producing particular pieces. Dry pressing is the moulding system that is used to make thin, flat pieces with regular geometry, and it's the most widespread procedure used in the manufacture of earthenware, glazed stoneware tiles and porcelain tiles. And as I say, it's based on the raw materials that are produced using wet milling, and the use of spray dried slurry has many benefits, largely due to the shorter drying time of the pieces and the minimum deformation, i.e. change of shape they undergo during firing. It also allows for very high production volume to be achieved with a high degree of repeatability, but it does require a lot of automation in the process stages.
Okay, so is all dry pressing the same?
Well, the theory's the same, but the methodology varies. Until a decade ago or so, all dust-pressed tiles were produced in moulds, i.e. a set volume of these dry particles were deposited in a mould, then a huge hydraulic press would descend to squash the tile flat. The resulting green tile, i.e. unfired, would then be decorated or glazed and fired, the so-called single fired process. The tile could also be fired and then decorated, twice fired, and for really high-end effects such as metallic glazes or vitrosa effects, the some pieces are even third fired.
So, but all that's changed?
Well, all these methods are still used, but the introduction of Superba or Continua rotary presses allowed tiles to be produced in continuous sheets that can then be cut in green or the unfired state before being sent to the kiln. Continuous pressing can produce large sheets that can also be cut after firing into smaller formats or modular, i.e. it's very flexible, it's very fast, it's very efficient, and you can also produce absolutely massive sheets in it. This is where the 3.6.1.8 metre monsters come from, and it's possible to produce things even larger than that, but you've then got to handle them. But yeah.
And are there any other options?
Yes.
As if we need more. I mean, this is all sounding quite complicated.
Well, yeah, as I say, the other options, which are plastic pressing, extrusion and slip casting, are all available.
Okay, so what's plastic pressing?
Okay, this is a system that's used to mould ceramic products with unusual shape. Basically, you're creating a mix of the same milled clay. You create it into sheets, and then these can then be formed in moulds to create 3D pieces like bullnoses or whatever.
So the clay has more plasticity, which is why it's called plastic pressing. It has more manoeuvrability.
Yes, I mean the plastic is simply a word to just it is its properties. I mean behaves like plastic, I guess. But with this one, essentially you're taking you're creating the mix you want. You're then adding the amount of water you need to create that particular shape, and again it is a case of it has got to be formable, but it's then got to hold the shape once you've formed it so that it stays like that while it's being fired. That's the key to it. And I say these are largely to produce special pieces that augment field tiles, so you will see things that are formed in this way being used with normal dust press tiles.
Okay, and you mentioned extrusion. What's that?
Okay, well, extrusion, basically you're taking a similar plastic clay body and you're pushing it through a head that creates the shape, and it's used to make ceramic products with a constant profile, such as the traditional baldus in Catalan, rustic stoneware tiles, or longitudinal elements, and this is where it's probably better known, which have a complex cross section. Again, this process uses dried milled raw materials to which water is added to get the required degree of plasticity. In extrusion, the ceramic body, as I say, is pushed through a die with the desired cross section, and the extruded piece is then cut or embossed to attain the desired size or shape. It is said that using extrusion can improve the mechanical strength of tiles because essentially it gets all the
it's under high pressure, isn't it? So
it's under high pressure, and it's the same way used to make a lot of things. Extrusion is a common process. I mean, it's how things like your plastic window profiles are produced and that sort of thing. It's a common technology, but it's very skilled, and there aren't that many real exponents of it. If you go to something like, walk around London Underground, you'll see a lot of extruded tiles were used there in the 1920s, and now there are very few people who can do this sort of stuff.
Okay, so finally, slip casting.
Okay, yeah, well, slip is the very liquid clay body. Casting is, as the name suggests, being put into a mould. And it's a really traditional moulding system used in the production of items with very complex shapes. It's widely used, for instance, for making vitreous sanitary ware. Your average toilet or basin will be often slip casted, but in tiles it's used to produce those special 3D pieces that you would see in a Victorian bar front, or the corbels on a fancy Gothic dwelling. The recent contract at Waddesdon Manor, where they've made a building that looks like a large wedding cake, uses an incredible amount of slip casted materials and other kind of moulded items. Basically, the standard way, this kind of emulsion, this clay mix, is poured into a porous gypsum mould which absorbs a certain amount of the water, and then it's left to dry, and it takes quite a long time to dry, which depends on the size of the piece, the thickness of anything, but you have to let it dry out completely before you can fire it, otherwise it just explodes in the kiln.
You did mention last week in the tile trends that 3D tiles are becoming a bit more of a thing. Are they all being slip moulded?
No, they're not. I mean, you can dry press to a certain degree. What you can't do with dry pressing is obviously have any design which is undercut, or where the piece goes underneath it, which you can do with a mould, because then you can take the mould apart and do that. If you're doing a dry press thing, they all have to basically go up from the flat surface. Where with moulding, they can go under as well as up. But yeah, and obviously it's a lot more expensive because it takes so much more time. You only get a certain number of pieces out of each of these gypsum moulds, and producing them is expensive, and you need a lot of skill. If you watch the people that do it, this is still very much a skilled handmade process, and you pay for the pieces accordingly.
Okay. Well, if anyone's still listening, because this is all very complex, that's brilliant. Well done for sticking with it. If there's a lot of information to take in there, then Joe is going to put a transcript of this up onto which website is this
going to put it up onto Transformational Tile Technology, and I'll put a link on Diary of a Tile Addict, so you can't possibly avoid it. Sorry, I mean, come on, this is Diary of a Tile Addict. I'm a tile geek. What do you expect?
And this is super geeky. This is getting down to the chemistry, but at the same time, if you don't understand how a tile is made, it's much easier to sell a tile if you understand it, isn't it?
Well said, Janet. I mean, this is largely why I believe that this stuff is important, because if you can have a very different conversation with either a standard householder, an architect, or an interior designer, if when they're looking at your tile, you can explain what's special about it. You can say, you see that glaze effect? That's created using a sinking ink or reactive glaze. You see how that's been moulded? That was slip cast. And then suddenly the question is not, why is it £50 a square metre, or each individual piece is 12 quid. It's, wow, I'm buying a piece of history. This is real engineering. I think that's very important.
And it also, I think, brings to light that it's important to understand that there is really fundamentally no difference between a red and a white bodied clay. And I know that certain regions of the world have preferences, and yet that's probably not well founded, really.
Right, you very neatly sequenced into next week's one, where I'm going to look at this, because I think there are a lot of common misconceptions about these things, and part of why you need to know how these things are made and what their properties are is so that you don't get bullshitted by somebody who's trying to sell you something that really isn't appropriate for purpose. And with most tiles, there is normally one tile that's more fit for the particular application, and if the other one is going to either cost you more to install, or it's going to require different adhesives, or it's going to be harder to cut. I have a bit of my bee in the bonnet about this, but we'll go on to that later.
Okay, well, I mean, certainly one thing I've taken away is I never realised how much clay came out of Ukraine, so I take nothing but that away. That's fascinating.
I mean, it's amazing. It's everywhere, but all clay is not the same. And you'll start, once you start to become aware of it, you'll see the geography of Great Britain in a very different way, and you'll see the clay. You'll follow the line up through East Sussex. You'll see it going through Humberside. You'll then pick up the band as it goes through Stoke-on-Trent and see where it ends up. It's very interesting. It's all about geology, folks.
It's taking me back to geology O level.
Yeah. Okay,
well, thank you very much, Joe. I think all the usual sort of housekeeping. Follow us, like us. If you do send information to Joe. We'll hopefully get back to some, if any news is happening, maybe next week as well, and we'll continue with more sort of technical and general features, I think, as well, that will just expand your knowledge of tiles.
Okay, folks, speak to you next week, and as Janet said, if you've got any stories for me, please send them to tileuk@aol.com. That's tileuk@aol.com. Thank you.
Okay, thanks a lot, Joe. You've been listening to Tilecast, produced by Diary of a Tile Addict. To ensure you don't miss any future episodes, don't forget to follow us. You can also find show notes and receive updates on news feeds, articles, podcasts and videos direct to your inbox by subscribing to the diaryofattileaddict.com website. Get the inside track at Diary of a Tile Addict.